So it says, so for activity B, what it's saying is, first, let's look at the top. And it says that you want to select that it's a convex mirror. So that means that it's the outside curve. So remember at the beginning of that, they talked about the spoon, like the outside, and then the inside of the spoon where you eat is the inside, the outside is the back end. So the convex is that curved outward. And so we want to set the light bulb at a certain spot, and then we want to put the focal point at a certain spot. And then what we're doing is we're trying to find the distance from the object to the mirror, or the center point, the 0. We want to find the distance from the image to the mirror, and then we want to find the distance of the focal length. So
Okay.
is if we put our light bulb all the way at 15, and then it said to put the focal point at 10, correct?
Yeah.
All right. All right. So then what we're going to do is we're going to find the distances of each of those things. So if we look at our object to the 0, okay, we want to find the distance for that one. We're going to put our ruler there, and we'll find our distance. Should be 15, since we're on the negative 15.
Okay.
For the distance of the object to the mirror. Okay?
Okay.
Then we're going to do the same thing, but now for the image. Touching the wrong things. There we go. We'll do the image to the front of the mirror, so that's 0. If I could do it perfectly, it should be right about 6. Struggling to move it today. All right. This is, I think, as close as I'm going to get it. So it should be right about 6 for the distance from the image to the mirror. And then the last one, we just put right here to the focal point, that blue dot, and that's going to be 10.
Okay.
So that is those first 3. So DO is the distance from the object, so your light bulb on the left side, to the image, to the mirror. F is that focal point, so that blue dot to the edge of the mirror. Then DI is your image, so the distance to the image from the mirror.
Okay.
So then, if you look at the table below for number 2, it just wants you to change each of the values. So you just pick 4 values. It's given you the DI and the F for 2 of them. You just got to find 2 more points, and you're just going to move and then calculate the values, okay?
Okay.
And then, so let's do this first one together, okay? So it says for trial 1, okay, we're putting our object at negative 15, and we're putting our focal point at positive 15. So then we're going to put negative 15, our object's already there. We're going to take that blue dot. We're going to take the blue dot, and we're going to move it to positive 15. And then we're going to find that DI. So that's the distance from the mirror to our focal point. So we grab our ruler. Oh my goodness. From the object's mirror to the image. So the mirror to the image is going to be 7.5. All right. So that DI, we're going to fill in that table right here. We're going to put in 7.5. Let's do this. So, sorry, 1 second. Right. So we have this one we did before. We said this was 15. This one was 10. and this one was 6, correct?
Yeah.
All right. Then we just did trial 1, and we found out that this DI is going to be 7.5. And it was a positive 7.5 if we want to put the plus sign, or if you remember that positive just don't have a symbol, either way. Now the next step is to go and find the 1 divided by DO. So we're going to put 1 over DO in a calculator. So 1 over 15, negative 15. And that is going to equal Did you get it?
Negative 0.06, repeating 7.
Perfect. I'm just going to put 0.067. We'll just round it there. Okay. Then we have 1 over DI. So that one's going to be 1 over 7.5.
Zero 0.13 repeating.
All right. We'll just go to here again. And then the last one is 1 over F. So 1 over positive 15.
Mm. 0.6 repeating 7.
Perfect. All right. So now that we have all of our values, okay, now it asks us to take those 3 trials, and what we're going to do is we are going to take this column right here, the DO and the DI, and we're just going to plug them into number 4, all right? So then
Okay.
we're just going to plug in the negative 1 over 15, or we can write it as the negative 0.067. Then we're going to plug in this one as the 1 over 7.5, which was really the 0.133. And now it wants us to take those 2 values and add them together.
Okay. Mm. 0.066.
Oh, perfect. Oh, wrote it down wrong. There we go. 0.6. Awesome. Okay, so now that we found that value, now let's take a look at 4A. So we can come up with this great information even though we haven't done 4 trials. We should be able to see something between number 4 right here, trial 1 of number 4, and trial 1 of number 2. Do you see any information that looks similar between those 2 besides the fact that we copied the same column here and here?
Mm.
Does this column look like anything from column 2?
The 1 divided by F.
The 1 divided by F, perfect. So what we can say is, and we should check this by doing the other 4 trials, but if we look, this 1 divided by F looks like it could be the same as the 1 over DI plus the 1 over DO. So something that we might notice is that the 1 over F could be the same as the 1 over DO plus the 1 over DI. So that's what we should be checking, is to see if that matches up when we do trials 2, 3, and 4. If those are the same thing after we do all 4 of our trials, let's see if they come out to be the same answer.
Okay.
And what we should find out is, if we look below, and if we remember from last week with the concave mirrors, that this does in fact work because it's our mirror equation, which tells us that those should be equal.
Okay.
And then the last two questions are just having you find one of the three values. So either you're finding F, you're finding DI, or you're finding DO. Do you want to go through one of those problems together?
Yeah.
All right. So now let's take a look. It says, if you place a light bulb at -8 centimeters, so I'm going to draw my light bulb like a candle because I can't draw. So, or like an arrow because I'm terrible at drawing. So 5, 6, 7 here. That's my beautiful light bulb. I know I'm a great artist. And then it says that our image of the light bulb is going to be located 6 centimeters from the front of the mirror. Okay, so -8 was on this side. So then 6 is going to be on the opposite side. So we're going to go past the mirror and we're going to find 6. And our image is going to be over here at 6. Just so we have an idea. And then this blue dot right now, this doesn't actually count because we're trying to find that and this image isn't real right now. So we're trying to find where that blue dot should be. And the blue dot right now is not correct.
Okay.
So now what we need to do is we need to set up that mirror equation. So we have our mirror equations 1 over the focal point equals 1 over the distance from the object to the mirror plus 1 over the distance from the image to the mirror. So 1 over F equals 1 over DI plus 1 over DO. And then DO, do you remember what we said DO was? Or where to find DO?
This-
Distance between.
Someone was saying it. Who had the answer? I think you guys were both saying right here, right? Okay, so what is this distance?
8.
Perfect. Except for one thing. So this time we're going to use that negative, okay? Because it's in the negative area. So we're going to actually include that negative symbol. So -8 right here for our DO. And then our DI is going to be this area. So what's our value for DI?
+6.
That's 6. Perfect. And then these are both centimeters. So I'm going to add those in just because we're going to have to add units at the end. And so now we can set up our problem solving for that 1 over F. So 1 over F is equal to 1 over -8 plus 1 over 6. Because we're just taking those values from up here and plugging them in. So now, if we find out what is 1 divided by -8.
-0.125.
Perfect. And then what is 1 divided by 6?
0.16 repeating 7.
We're just going to round to 3 decimal points again. Okay, so now what we're going to do is we're going to add those two numbers together to find out what 1 divided by F is going to equal.
0.042.
Perfect. Okay, so we're looking for the focal length of the mirror, correct?
Yeah.
So right now what we have here is 1 divided by that focal length of the mirror. So to find out what the focal length of the mirror is, we're going to flip all of them upside down. So what that means is if we want to find F, we take 1 divided by that 0.042 to find our answer.
$23.8.
Perfect. All right. And then that is your answer for your focal point. And then just because we rounded a little bit, it's going to actually be a little bit different. If we didn't round, it should be just about 24. Okay?
Okay.
So just because of rounding, it comes out a little bit different, but that is perfect. So our focal point, if we put it on here, would be right around there. And that's all you have to do for this problem.
Okay.
All right?
Sounds easy.
All right. Any other questions?
No.
All right.